Hello everyone, in this video we'll discuss a numerical on balancing of V engines. So in V engines we already know that two connecting rods they run a common crank shaft. So in the question we are given that the cylinders of a V engine they are set at 60-degree angle. That means the cylinders of both the engines for both the pistons they are at this angle is 60-degree, which is equal to 2 alpha, right? So alpha, that means the angle which they makes with the x-axis. So alpha is 30-degree. Now each connecting rod length is 600 mm. So this is 600 mm, and the crank radius, which is r, the common crank for both the systems, is 120 mm. Rotating mass is given, which is 2 kg, and the reciprocating mass is 1.2 kg per piston, right? Because there are two pistons, so for each piston the reciprocating mass is 1.2 kg, and a balance mass is fitted opposite to the crank, which is 2.2 kg at a radius of 150 mm. So we have to find the maximum and minimum primary and secondary forces if the engine is running at 800 rpm. So this is the system that we have. We have got the two cylinders, right? And the mass of both the cylinders is denoted by small m, which is 1.2 kg. They have a common crank and the mass is given as capital M, which is 2 kg. The length of both the connecting rods is small l and length of the crank is small r. And in the question it is given that to balance the unbalance produced because of the reciprocating and rotating masses, there is a counter mass which is being added opposite to the crank. So this is the counter mass, and this mass is m dash at some radius r dash, which is already given in the question. So because these are the opposite angles, right? So if this angle is theta, this angle will also be theta, which the counter mass makes with the x-axis, right? So we know the values of L and R, so we can calculate N, which is L upon R. Speed is given 180 rpm, so we can calculate omega, which is 2 pi N upon 60. Now, for the unbalanced forces, the equation for the force is mr omega square cos theta, where this is termed as the primary force, and mr omega square cos theta upon n, which is termed as the secondary force. And in the question we have to find the resultant primary and the secondary forces. So firstly, we'll talk about the forces along the x-axis, right? So the primary force along the x-axis because of both the connecting rods is 2 mr omega square cos square alpha cos theta. Now this we have already derived, right? And how we derived? We said that the primary force is mr omega square cos theta. Theta is the angle which the crank makes with the line of stroke. So in case of first cylinder, the angle which the crank makes with the line of stroke is theta minus alpha, which is theta minus 30 degree, and in second case it is theta plus alpha. So for both the forces, their x component will be the cos factor, right? Cos theta factor. So when we add the two factors, we get this equation, and we have already done the derivation in another video. Now along the x-axis, the another force that is acting is because of the rotating masses. This crank which is rotating, right, it is having a part of its centrifugal force along the x-axis. So what is the centrifugal force? It is m, capital M r omega square, and its component along the x-axis is mr omega square cos theta. The third one is the balance mass which we are using, which is m dash. So it is also rotating at some speed. So the component along the horizontal component is this force, right? So which is in the direction opposite to the direction of the centrifugal force produced because of the crank mass or the masses at the crank pin. So this is negative of m dash r dash omega square, and because the force is produced here mr omega square, so along the x-axis it will be cos theta. So the total unbalanced forces on x-axis will be sum of all the three forces. So we add them, we take all the common factors out, which is omega square cos theta, and we know all the values. We know alpha is 30 degree, capital M is given, which is 2 kilograms, small m is given, which is 1.2 kilogram, and m dash is 2.2 kilogram, r dash is 150 mm. So we place the values and this is what we get. And theta is unknown. We do not know the value of theta, right? That we have to calculate. So this is the unbalanced force along the x-axis. Similarly, we can calculate the unbalanced force along the z-axis, because whatever the unbalanced force because of the prime reciprocating mass, it is along the line of stroke. So its horizontal component is the cos theta and its vertical component will become the sine factor. So we get the value which is 2 mr omega square sine square alpha sine theta. Similarly, for the crank, because the centrifugal force is in this direction, its z factor will be mr omega square sine theta, and for the counter mass, it will be in opposite direction. So it will be minus mr omega square sine theta. So this will be subtracted, right? So we get the common. Now to get the resultant or the total force along the z-axis, what we do? We add all the three forces that we have calculated, the primary force and the centrifugal forces, right? So omega square sine theta is common. We take it out of the bracket and we place all the values, all the known values that we already know. So this is the total unbalanced force that we get along the z-axis, which is minus 217.8 sine theta Newton, because sine theta is the value that we have to calculate. So the resultant primary forces will be the resultant of the forces along the x-axis and the z-axis. So under root of this horizontal component plus the vertical component, it will give us the resultant, and this angle is the theta along which the resultant is acting, the beta along which the resultant is acting. So this is the value of the resultant primary force that we get. So the maximum force is like generated, or the maximum force is produced when theta is 0 degree. So when we place cos 0, it is 1, and sine 0 is 0. So we get the maximum force, and when theta is 90 degree, we get the minimum force, which is 217.8 Newton. Now we have to also calculate the secondary forces. Now secondary forces are mr omega square cos 2 theta upon n. So using this equation, we can also find out the secondary forces because of the cylinder 1 along the line of stroke and cylinder 2 along the line of stroke. So once we get the values, we can find their components along the x-axis and the z-axis. So while finding their components along the x-axis, it becomes cos theta for both, cos alpha for both cylinder 1 and 2. So along the x-axis, secondary force is this, which is 2 mr omega square cos 2 alpha upon n and cos 2 theta. And along the y-axis, the force that we get is along this axis, right? Along the z-axis. So one will be in this direction and another one will be in the opposite direction. And because we know the values along the x-axis and the z-axis, we can find the resultant easily. You take all the common factors out, place all the known values. We know what is alpha, right? We know what is mass of the rotating parts, mass of the reciprocating parts, right? And we get this equation, and this gives us the maximum. Whether you place theta 0 degree or 90 degree, we find that the maximum and minimum secondary force, it remains the same. Now one thing to note here is that the centrifugal force effects because of the masses, it does not affect the secondary force. Therefore it is not taken into consideration, because the rotating masses, they are because of the second harmonics of the piston acceleration. Therefore their factors are not counted, and we are only taking the secondary force which is produced because of the unbalance of the reciprocating parts. And this equation also tells us that the value of the secondary force, it remains constant. The maximum and minimum value remains the same in the whole system.